Integration Made Simple by Anil Kumar. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are taking up integration by U substitution. We have three examples to work on. We'll see how do we define the variable u so that the derivative and the function part can be related and the method of substitution can be utilized. So we'll do these three examples now. Let's try to look at it first and understand the strategy. The idea is to write the function as f of u du with some constants we could multiply with, right? So let's say k, right? So in the very first one, what do you think should be u? What do you think should be u for the second and third? You can think about it. Meanwhile, let me thank all the viewers and subscribers for watching my videos, posting excellent comments and suggestions. Your suggestions mean a lot, and your valuable donations help us. As you know, we have been serving absolutely free for our last 15 years, and now we have more than 17,000 videos, which are being watched over 80 countries. We want to reach globally millions of students who cannot afford quality education. You can make it possible. So, contact us on the email and make a change. Let's look into the set 3. So, this is our set 3. We already have done set 1 and 2. So, let me share with you the practice questions series. As you can see, there are quite a few here. So, set 1 and 2 already done, and this is the set 3 which we are looking into. So, complete solutions will be provided by me in the playlist, and there are many more questions to work on. Great. So, let's see what kind of substitution you would like to make. So, denominator x, that means 1 over x, right? So, we could substitute that as u here. In this case, you could substitute sine or cosine, doesn't really matter. So, let's say cos x as u, and in the third case, the one with the square root sign, 1 plus cos x, will be a good substitution. Doing this substitution, you can easily get your integration correct. So here du is ln x, right? dx. And here du is minus sine x. And here du is minus sine x. So what you see is that the derivative is the other part. You get the idea. Right. And that is how you can write the expression as f of du dot du and integrate it very easily. Correct. So let's see one by one how do we do them. And well, in case you want to learn from me directly, feel free to send an email on globalmathinstitute at gmail.com. Our students are right there on the top. They understand the concepts, their foundations are great, and therefore, even in universities, they are getting 100% marks. So let's look into the very first question, which is integrate ln x over x. Ln is log to the base e. So our substitution here is u equals to 1 over x, right? So du is ln x dx. And therefore, the expression, let me rewrite it as, let's say, 1 of x, right? And ln x dx. Makes sense? So 1 over x is u and ln x dx is du. And now we have integral of u, right? With respect to u itself. Perfect. And that is u squared half. And don't forget to write c, right? Because the function, which vertical translation, substitute back the value of u, which is 1 over x, and u. So you get 1 over x whole square, or you can write this as 1 over 2x square, right? So I hope this is absolutely clear. So made simple, right? So we have made this integration so simple for you. Here, we discussed putting cos x as u, but you could put sin x as also u, right? So let's say u equals to sin x, right? In that case, du will be equal to cos x dx. Makes sense, right? So, so the integral, which is cos x sin x dx, I could write this as sin x times cos x dx, right? And so we have sin x as u and cos x dx is dx. And cos x dx is du, right? And therefore, once again, when you integrate this, you get what? You get half of u square, right? So applying the product rule, it becomes so very simple, and definitely half of u sine, so sine square x. Makes sense. So that becomes your answer for this plus c, of course, because it's an indefinite integral. There could be any constant. Correct. Now here is the last question for us to do: sin x square root 1 plus cos x dx. And in this case, we have no choice but to put u as 1 plus cos x. And definitely du will be derivative of 1 is 0, and for cos x is minus sin x dx. So now we could rewrite this as integral of square root 1 plus cos x. I'm just rearranging, not really required, okay, but just to make it absolutely clear. So you see, we have here sin x dx as du minus sin x dx, correct? So therefore, when you rewrite this, minus, don't forget that, and square root of cos x is square root of u now, and du. Makes sense, right? So this is minus u to the power of half plus 1, which is 3 by 2 over 3 by 2, right? Or you could write this as minus 2 over 3 u to the power of 3 by 2. And you could write this u as 1 plus cos x, right, to the power of 3 by 2. And don't forget to write c here as a constant. Perfect. So with that, we come to an end of this particular video in which we have integrated all the three in set 3, right? All the three integrals we have found by substitution, which we discussed. In one, we had a variation, right? So I hope that really helps. So thanks a lot for your help. In case you want to support this beautiful channel, which is your channel, we are actually helping you out by providing you with some examples which you really need to go through. Perfect. So in case you want to really help us, feel free to contact us on the email globalmathinstitute gmail.com. Also, you can contribute directly, especially if you are in Canada, with the email. Thanks a lot for your time and all the best.